G'day viewers, Alan here. Thanks for joining me in the workshop. So in this video I want to make a tool setter for my NT40 adapters. So I made one previously, and this one is designed to sit in the vise, and the idea is that you can then put the adapters in there to work on them when they're not in the milling spindle. It's not a must-have, but it's a convenience thing, and I've been really surprised at how much I've used this thing. So much so that I've decided to make one to be a semi-permanent feature attached to the milling table. So let's have a look at how I did it. Right, so I've got a suitable piece of scrap in the 3-jaw and the roller aligning tool here to get it running true in the chuck, or as true as that front face actually is. So I had it pretty right actually. But anyway, you can see how quick and easy that is to get it sorted, because you can probably see I'm only holding this bit of scrap by its tippy toes. Okay, so now I've got this thing running somewhere near true. I'll take a facing cut across here. Not worried about surface finish at this stage, but I will try up the hole in the middle because I want to mount it on this stumpy little arbor. It's 25.4 or an inch hole. Right, well let's see if we can start boring this hole and getting it to run true. So the hole is nominally 20, but it's off centre. Let's get the hole cleaned up, running true. So we'll start checking the size now. Right, well with this pass we'll be aiming for 23. So we were set for 23 then. Let's see what we finished up getting. This thing can be trusted. We're right on 23. So that was 25.4. So I should be able to find something that's an inch diameter and get an accurate reading instead of relying on these other instruments. So I don't know whether you'll be able to read that, but Moore and Wright have given me their assurance that that's 25.4. I'd say my hole's about 25.4. That will just go in. So it looks like we're on size for 25.4 anyway. But I think this guy's just a little bit bigger than that. Yeah, so we've got to go up a bit more yet. The trailees are back next door. So this is pretty close now, so what I'm going to do is mount this in the chuck and then machine this or hone this to make that fit on it. I went for 25.4 then. Oh. And I think that would go on with the nut behind it. Yeah, it's going on nicely. Not going to be any slack there when the nut's tightened up. Right. Okay. Now I can bring the OD of this down to size. So I think we'll slow it down a bit. Set at 57. Pretty close. Now I machine the mating parts of this to suit, so 53 is what we're shooting for. That's cooled off now. Don't play around with that stuff, Alan, that's dangerous. This is what pliers are for. Alright, so we're shooting for 53. So we're making the mating part, so hitting it exactly isn't critical. 52.97 mil, that's pretty good, I'm happy with that. Right, so that's got the OD to size, or the major OD. The next feature to put on there, I need to machine this end down to 49 and create a shoulder up here, which will be 2mm wide and 2mm deep, I guess. Hopefully that's somewhere near 49. You gotta laugh when that happens, don't you? Anyway, so that's my shoulder that I wanted. So now I can take this off the arbor, turn it around and stick it in the chuck up against that shoulder. It turns out this is such a tight fit on the arbor, I can actually take a skim here, even with the nut missing. So we'll do that, just take a final little clean up pass. That worked out right. So take it over to the vise and knock this arbor out. So that's my insert ready now to have the NT40 taper put on the inside. Whether I can be bothered putting protection. This is pretty tough stuff. This must be 4140. It's quite tough. So I won't be taking heavy cuts on it. Let's make sure that's seated up against its shoulder. Sounds pretty solid, doesn't it? Right, so I'm getting set up now to set the compound or top slide to the correct angle for boring my NT40 taper. Now the angle that I need to have this set to is 8.297 degrees. Well, clearly I won't be able to set that accurately just on the scale on the cross slide. So we use a thing called a sine bar instead. If you recall your trigonometry, the sine of an angle is the opposite over the hypotenuse. In this case, the hypotenuse is set by these two pegs, the contact points of these two pegs, and it's designed to be exactly 5 inches. So knowing that and the angle I want, you can work out how big a stack of spaces you need here. So I've used gauge blocks and it needs to be 18.327 millimeters. And with that set, we can run the dial gauge backwards and forwards and see that this is in fact at the correct angle. So hopefully that's in focus and you'll be able to see that I've got this correctly set and it's tracking pretty accurately. So now I can be pretty confident that I've got the top slide set at the right angle. Alright, well let's do a first cut and see how it looks. See if we can get any sense of what diameter it's cutting at. I think getting to the right answer is going to involve a bit of trial and error. I've locked to the carriage, so my only way backwards and forwards at this stage is with the top slide. It's about 26.5 there. Alright, so we come back this way 0.5 millimetre, 27. Seems to be cutting that alright. Let's try a millimetre. Let's come back to 28. looks like we're cutting at full depth now, so I can probably do my first try. Doesn't seem to be matching up terribly well. Oh, I was getting confused with this thing, I think. No, that's that's all right. So we're sitting with an opening at the moment of about 32, and it needs to be about 45, so we've got a ways to go yet. I'm only taking a millimetre off the diameter. I might try taking 2 millimetres off the diameter and see how that goes. So I'm up to 36 now, and it's looking good. For people not familiar with the NT40 taper, it's not a locking taper, it's not meant to lock, it's not like a Morse taper which is locking. It's designed for quick release. We're in at 38 this time. So I'm going to start paying attention to surface finish now. That's not fantastic, and this insert's done a bit of work, so I think while we've still got a bit of time up our sleeves, I'll switch the insert out or turn it around to a new corner. That corner had definitely gone, and the other one was looking a bit second hand too, so time for a new insert. Alright, let's see how we go with that. Now, where was I up to? That's definitely a big improvement in the surface finish and the way it was cutting. Alright, so we'll take my last 2 millimetre cut. And that was 44, and I should think that'll be getting us pretty close. That is indeed close. Oh, that's got a good hold of it too. Right, well, I'm wondering whether, for my purposes, whether there's any point trying to do another cut. That actually is pretty good. I'll try 44.2. The surface finish now is actually pretty good. So I'm thinking that's probably going to be my last cut. Yep. I'll call that done. Let's break that corner. And last check with the size gauge. I'm happy with that. So I'm going to make the bracket out of a piece of this a disreputable looking object. It's 4 inches by 4 inches by 3/8 or 10 mil thick, and I think, if I remember correctly, I actually acquired this when I was living in Darwin about 40 years ago. It was originally somewhat longer, but it's given up various pieces of itself for projects along the way. It's just mild steel, so it actually machines quite nicely. But with the light behind it, I think you can see that it's not particularly square, but it's probably not bad for hot rolled angle iron. Anyway, that lack of squareness on the inside won't be an issue for this job. So I hacked a piece off, and got it and cleaned the sides up, and I've mounted it so I can clean the two outer faces up and square them to 90 degrees. So we'll kick off with a 0.2mm depth of cut and see what we get left with after that. We're doing 600 RPM here because it's quite a reasonable size swing. That got a bit smoky, didn't it? Well, that got most of the way there. I'll see if I can get a feeler gauge and work out how much more would be required to clean that up. So another 0.3 would get a lot of it. We'd do a total depth of cut of 0.8 out of my 10mm, so I think we can tolerate that. And the top edge of the milling table has got a big chamfer on it anyway, so this area here isn't going to contact the face of the milling table in any case. So I think we'll take another 0.3. Yeah, I think that'll be fine. So that margin there, as I said, will line up with a big chamfer on the front edge of the milling table, so there wasn't going to be any contact there anyway. Alright, so we'll turn him over and do the other side to get our square. Okay, so I'll flip this around and face this side at 90 degrees to the first side, and I'm ready now to set the socket which I've machined to match the NT40 taper, to set that into the bracket. And to give it a racing start, I'm going to use a 38mm annular cutter, which will leave, well, the hole will be about 4 or 5mm undersized on the diameter, and I'll use the boring head from that point. Yeah, there's a hole left over from previous life, not worried about that. Let's give it a bit of a squirt of this stuff. And get started. Now I think slow is the go here, so we're going to have back gear. And I don't know what speed, 70 I'm on at the moment. Let's see what that looks like. Well, that doesn't look too bad, maybe a bit slower. Yeah, let's give that a try. It's certainly getting through it though. We're at least 3/4 of the way through, maybe more. And there we have it. I'll be a bit of heat around there, so I'll just be a bit careful with a bit of a clean up. You've got to love these cutters. They leave a really clean hole, don't make much mess, and as a bonus you usually get a slug that you can reuse for something. Although in this case, obviously I won't be reusing this one, but it does highlight another benefit as well, in that because of the cutting action, the hole that I started from was way off centre and out of position. So it allowed me basically to move the hole over to where I wanted it to be. That wouldn't have been so easy if I was just trying to do it with drills, end mills and such. So yeah, there's nothing to dislike about these guys, apart from the cost perhaps, they aren't that cheap. But yeah, they're good bits of gear. Alright, so set up now with the boring bar. This cut will be about 0.73 off the diameter, and I'm just trying to get myself properly set up and calibrated at this point. We'll go at 800 RPM and see how that works. Finished up on 40.09. Right, so at least I know where I am now. Alright, so I'm still trying to get myself dialed into sizing properly. So we're currently on 42.14. I'm going to shoot for 43. So I've got to take 0.86 off, which is 4 full turns and 6. So let's see if I can do that without messing it up. And I slowed it down slightly. We're running at 700 now. I'm not worried about the terrible surface finish because I'll be pressing the thing in with a bit of Loctite. But let's see what size we got. Not that easy working with these things on something that isn't terribly thick. Alright, let's see how close we got to 43. Oh wow. Looks like I've finally got this bugger under control. As close as to 43. That's as close to 43 as I need to be. Right, well let's press on. My target end state is 48.98, so I'll bring you back when I'm somewhere near that. Okay, fingers crossed for the last pass. 0.03 should take us to 48.98. I think we finished that right on the size I was aiming for. It's 48.98, 48.92, and as I say, the thing that's supposed to go in there is 48.99. So I am going to take another cut at point with a 0.01 off the diameter. Right, that has just started. So that is going to press in beautifully with the Loctite. So that's finished that major diameter. Now I've got to do an inlet around the top to accommodate this shoulder. I've been checking the size for the calipers because it's the best option I've got. 52.99 by the look of it. I guess that's pretty close. Let's see whether this thing's interested in looking at the hole yet. I think that would press in, but I think I'll go another 0.01. Go one and a bit actually. Yeah, that's what we want. I just felt it start to go in. That's perfect. Alright, clean up time. Okay, so ready to press this guy in now. So I can make sure it gets fully seated. I've got this bit of scrap here with a few diameters that I've turned on it. It's a useful press tool. Anyway, that will allow me to press to make sure that this shoulder is fully seated in the bottom of the groove. Alright, let's get the Loctite on and get squeezing. Let's get that piece smarmed up. Got someone here. It's going to be Loctite from Wotsits to breakfast when this goes in. I've just got so much of it, but I'm just not quite sure how to make sure some stays where I want it to be. Alright, let's see how we go. Good start, Alan. I've got more of it on my fingers than anywhere else. Right, let's start getting a bit of a push and see if it's it's as far as it's going to go. Start wiping some of this excess off, and I think you'll be able to see that's gone in. You can see that's gone in nicely. Anyway, I'll get it cleaned up properly and you have a better look. I'm not sure whether I made myself clear before, but when I went to push this thing in, I wanted something which would locate on the inner diameter but be able to press within the OD, and that's what this was for. It just has various diameters on it, and a couple of them, one was enough to fit inside there, and then the next one out was smaller than that, so it guaranteed that this could be pushed, if necessary, past this surface. As it turned out, it wasn't necessary. They finished up pretty much flush. But anyway, so that's what I was waffling on about earlier. So back in the milling vise, and this time I want to cut slots or grooves, channels, for drive dogs in here. Now typically these dogs are 16mm wide, 16mm deep, and they let 8 into one side and 8 available for engaging with the cutter on the other side. But my material here is 9mm thick, so I'm going to make the slot 2mm deep, allowing for 8mm of thread engagement. But I think that'll be fine because the dog should just be in straight shear, so I think that'll be strong enough. In any case, that's what I'm going to try. So we'll go first pass at 1.5. I'll just go straight across and we'll see how that goes. So as for speed, I suppose 1000 RPM, something like that. Right, we'll just clean these chips up. So that's a 12mm cutter. We'll just check to see what size groove it left behind. Really tight on 12, it doesn't, 12 doesn't want to go in. Okay, so 11.95 is where we're at. I want to open this out to 16, so basically I've got to take 2mm off each side. Right, so there's 16. I think you'll be able to see that that turned out to be pretty much perfect. And thankfully it's the same on the other side. So I decided to show the bandsaw a bit of love and cleared out the old coolant, which was well and truly past its use by, and so what you're seeing there is clear fresh coolant, and cleaned the chip tray out and all, so yeah, it does a good job, deserved a bit of attention. So this is the piece of steel you just saw me cutting up on the bandsaw. It's actually a tow bar tongue of all things, and actually this thing here was made from the same piece of scrap. Anyway, by the by, so I'll get the 2 dogs out of drive dogs out of this piece, and this piece at the back here will be made into a T-nut to fix it to the milling table. So as you can see, I try to minimise waste in my workshop. Well, moving on, I've cleaned up the piece of stock that I want to use for the long T-nut. It'll be a single piece, and I'm set up now to cut the shoulders. And I'll be using this cutter here, and it's set to cut 8mm wide and 1mm deep, and I've got to go ultimately to 4.4 deep. So we get started without the coolant, but then I'll have to turn the coolant on. So I've milled the two pieces to be dogs up, and as you can see they're pretty close to fit in the slot. They will press in now. So I'm going to hold these in place with an 8mm clamping screw, and I've doctored the head slightly to make it a little bit smaller and slightly shorter. But yeah, it's an M8 screw. I'm going to have a 17/64 hole and tap him out to M8. Right, repeat on the other side and then drill the holes in the dogs. I'll switch over to a 1/2" end mill to do the counterbore. Alright, so hopefully that'll drop in there. Nice, and hopefully it'll fit the piece it's intended for as well. And now I've got to do the other one. Alright, well, I finished making all the parts, and it's time to see if they'll go together. So since you saw this guy last, I've cleaned it up, rounded it off and put a hole pattern in the back for mounting it. And that hole pattern's matched by this T-nut. So let's start there, assembling the T-nut to the back. Right. So obviously the T-nut happily goes on the back of the bracket. And I made the T-nut quite a snug fit in the front of the milling table. So I didn't want it moving around unnecessarily. And they'll go in there like that. And tighten these bolts up. So obviously this could go anywhere along there, but my idea was to have it on the left hand end, keeping it out of harm's way. Or stopping it from interfering with anything that I'm doing on the milling machine, I should say, maybe. Okay, so that's got that on there quite firmly. Typically T-nuts are loosey-goosey in the slots, but in this case I wanted it to be a close fit. Because most T-nuts have got to be in and out like a fiddler's elbow, but this one's semi-permanent. Alright, so we put the drive dogs on now. They are quite a close fit in their slot. There you go. And there it is. Alright, so let's see if it works. This guy here has had a starring roll in the thing, so it's only fitting, but that's a really snug fit in there. And this one's usually on pretty tight. I don't know whether you'll be able to pick this up. There you go. Yeah, so I think it's actually going to be quite useful just having this spare station for when you're switching backwards and forwards between a couple of adapters. There's somewhere to put the one that's not currently being used. And I think where this will be particularly useful too is for slitting saws. When you're trying to work up, so if you set the slitting saw in the machine, you're working upside down to assemble the stack of spacers and saw. but here you can work the right way up. Well, I reckon that turned out pretty well. I'm certainly pleased with it. I think it's going to be a very useful addition to the milling machine. Well, thanks for watching, and look forward to seeing you on the next one. Cheers.